Hey students, before you get started with this video, make sure that your math notebook is in front of you and open to the next blank page. You are going to want to take these notes on the right-hand side, and then when you get to those Edpuzzle questions, you can show your work on the left-hand side. Okay, so for this video, our title is going to be 1.3 Order of Operations. And you will be watching this video on September 10th, 2020. Our learning target for today is I can evaluate numerical expressions using the order of operations. Now, I'm sure there are some words in there that you're like, what does that mean? And that is the very first thing we're going to talk about. So our first vocab word, not worm, is numerical expression. And a numerical expression is just an expression that contains only numbers and operations. So we could have something like 2 plus 2. We've got numbers and an operation. We could have some exponents. Exponents are a type of operation. It could have some sort of parentheses. All of these would be examples of numerical expressions. They contain only numbers and operations. Our next vocab word is evaluate. To evaluate means to find the value of something. So to find the value of. For example, if we were asked to evaluate 2 plus 2, we would say that is 4. We evaluated it, we found the value of 2 plus 2, which is 4. And then our last vocab word is the title of the section, order of operations. The order of operations, these are the rules we use to evaluate expressions. So in this section, we are going to use the order of operations to evaluate, to find the value of numerical expressions. And now we're actually going to talk about what the order of operations really are. So the order of operations, the best way for us to remember them is going to be by using an acronym. That is where we take words and we use the first letter in each word to create kind of a new word. And our acronym here is going to be GEMDAS. G-E-M-D-A-S. GEMDAS. Most of the time you'll hear PEMDAS, but I'm going to use GEMDAS and you'll find out why in just a second. So GEMDAS tells us each letter stands for a certain kind of operation. So when we evaluate a numerical expression, we go through each letter, and that is the order in which we perform those operations. So first we start with G, and G stands for grouping. So that just means at the very beginning of evaluating a numerical expression, we want to look for grouping symbols. So grouping symbols could be parentheses, could use brackets, and one that's forgot about a lot of times is the fraction bar. So I know that a fraction bar means division. Hopefully you know that as well. We've talked about that in a previous video. But a fraction bar also groups things. It groups the top and bottom. It creates two separate groups. So we'll do a couple of examples of that later on. So if you're a little confused about why a fraction bar is a grouping symbol, that's okay. I will explain it again in a minute. Once we've taken care of grouping symbols, Then we move on to E, which stands for exponents. So then we look for any exponents and we evaluate those exponents. The next two letters, M and D, these ones actually go together, and they stand for multiplication and division. The reason these go together is because we don't always perform multiplication before division. We actually treat these as pals. What I mean by that is once we get to this step, we look through the entire problem from left to right, and we perform multiplication and division, whichever comes first. So I take my pencil and I go through the problem left to right, looking for multiplication or division, and whatever I happen upon first is what I do. And then our last two letters, A and S, those stand for addition and subtraction. These ones also go together. We also perform these from left to right. Left to right. So once we get to this step, again, we take our pen or pencil, go across the problem, looking for addition or subtraction. Whatever we see first is what we do. All right, I know that sounds like a lot, but let's do an example of how this actually works, of how we use these when solving, when evaluating and numerical expression. So our first example is going to look like this. We have 30 divided by the quantity of 7 plus 2 cubed times 6. Okay, so we have this numerical expression here. It looks kind of tricky, but what we're going to do is we're going to go through each letter of GEMDAS, and we are going to use that to guide us through this problem. So first I look for grouping symbols. I see there is a set of parentheses here. So that means I want to do whatever is inside the parentheses first. Well, in the parentheses, we have addition and an exponent. To decide which of those to do first, we just go through GEMDAS again. So I say, okay, what comes first, addition or exponents? Well, exponents is higher on the list than addition, so that's what we're going to do first. Remember, 2 cubed means 2 times 2 times 2. And that is 8. So what I'm doing right now is I'm rewriting the problem and only replacing that one number that I just found. So I want it to look exactly the same except that one step that I just did. All right, now I can finish out the parentheses by adding those two together. 7 plus 8 is 15. And again, the problem is rewritten the exact same way. The only difference is that single step I did. All right, now I've done my grouping. I don't have any more exponents. So now I can move on to multiplication and division from left to right. So what I do is I take my pen or pencil and I go across the problem and I look for multiplication or division. Whichever I hit first is what I'm going to do first. Well, it looks like the first thing I see is division. So that means that's what I'm going to do first. Again, even though M comes before D, these go together. We go left to right doing whatever we see. 30 divided by 15, that is 2. Still times 6. And to finish out the problem, 2 times 6 makes 12. So the value of this expression ended up being 12. All right, hopefully it's starting to make a little more sense. We're going to do 2 more examples to really make sure we've got the hang of things. So example 2 looks like this. We have 8, and then in parentheses 3 plus 4 over 7. So at the bottom, I'm going to write GEMDAS just to remind us. So G, grouping. Do I see any grouping symbols? There's actually 2 different grouping symbols here. The first one is this set of parentheses, right? That's telling me I should probably add these 2 things together. But the other grouping symbol is the fraction bar. Earlier I said that the fraction bar is a grouping symbol. What I mean by that is that when there is a fraction bar, now our problem, our expression is split into 2 groups. The top is a single group and the bottom is a single group. So when we see a fraction bar, we have to evaluate each group separately, the top and the bottom separately, and then we divide as our last step because a fraction bar also means division. So if I start on the top, I see grouping, and that's what I'm going to do first. 3 plus 4, which is 7. And again, I'm going to rewrite the problem exactly the same way, only doing that single step, making that single change. All right, now we see a number directly next to parentheses. Whenever we see that, that just means multiplication. So if there's no operation between the number and the parenthesis, that means that they are being multiplied. So to finish out the top group, we do 8 times 7, which is 56 over 7. All right, we evaluated the top group. The bottom group doesn't need to be evaluated. It's already a single number. So that means now to finish out the problem, we divide, because a fraction bar means to divide. 56 divided by 7 is 8. So the value of this expression is 8. All right, one more example here. Example 3. This one, we have 12 squared minus 4 times 6. Remember, when a number is directly next to parentheses, it means multiplication, plus 1, all over 11 squared. So I go through GEMDAS looking for G first. Well, look, this expression has a big fraction bar through it. Remember, that tells us that now we have 2 separate groups. We have the top group and the bottom group. So first, let's evaluate the top group. In the top group, I do see parentheses, but there's nothing to actually do inside the parentheses. So we're going to move on to exponents. And I do see exponents right there. 12 squared, which means 12 times 12. And that is 144. So I rewrite the problem, just making that single change, that one step that I did. Now I can move on to multiplication and division in the top group. I do see multiplication. That's the only thing I see for that step. 4 times 6, so that's what I'm going to do next. That's 24. So I just replace that single number and rewrite the rest of the problem the same way. Now I can finish out the top by doing my addition and subtraction. Again, we don't automatically do addition first. We just go through the problem left to right, looking for either of those operations. So if I go left to right, I actually see the subtraction first. So that's what I'm going to do first. 144 minus 24, that's 120. And to finish out the top group, 120 plus 1 is 121 over 11 squared. So I've evaluated the top group, but the bottom group, we still have to evaluate that. All that's there is exponents. We have an exponent, 11 squared. That means 11 times 11. Let's just do that over here real quick. 1 times 1 is 1. 1 times 1 is 1. Placeholder. 1 times 1 is 1. 1 times 1 is 1. Add them together, and you get 121. So now my problem reads 121 over 121. Now that both the top and bottom groups are evaluated, we can finish out the problem by dividing, because the fraction bar means to divide. 121 divided by 121 is 1. So the value of that expression is 1.